Welcome to my video, Introduction to Vectors in Physics and Math. What is a vector? A quantity with both magnitude and direction is called a vector. Examples would be force, velocity, acceleration, and there's lots of others too. The length of a line segment represents the magnitude of a vector, the direction indicated by the relative position of the initial point, P, and the terminal point Q. So this gives us the magnitude represents the length of it, and the direction tells us which direction the energy, the force, velocity, acceleration is going. Vectors indicated by a boldface type, or sometimes we'll put an arrow or a little hat over a symbol to indicate that it is a vector. What is a scalar? Now this is different than a vector. It's a quantity with only a magnitude is called a scalar. This might be like a mass, a length, time, temperature, many things that we see in everyday life just are numbers. Now, how do we show the equivalence of vectors? Two vectors are called equivalent if they have the same magnitude in the same direction. This example, R and S are the same. They have the same length. They're going in the same direction. So these are two equivalent vectors. Now, if we compare S and T vector, see, it's a different length, a different direction. So S and T are not equivalent vectors, as well as R. A zero vector, this is defined as a vector with zero magnitude and denoted by a bold face 0, just nothing to it. Addition of vectors. Given V and W, two vectors, V and W is the vector formed as follows. Place a copy of W in the initial point, coincidence with the terminal point of W. The vector V plus W has the initial point of V and the terminal point of W. So there's our V vector. Now we add the W vector to it. We go to the end of the V vector to put the initial point of the W vector, and then we draw a line from the initial point of V to the final point of W. So that's how we would draw this is the triangle method. Now there is another method for doing this called the parallelogram method. So in this method, we've given the vectors V and W. V plus W is the vector formed as follows. Place copies of V and W with the same initial point. Complete the parallelogram, assuming V and W are not parallel line segments, and it's not going to work. And V and W, but you could use the other method if they are parallel. If the V plus W is the diagonal of the parallelogram with this initial point. So let's look at a diagram and make sense of that. Okay, here's one vector, the V vector. Here's our W vector. We want to add those two together. We're going to form a parallelogram. There's the top of it. There's the side of it. Now we draw a line from here to here, and that's going to be our resultant vector. So it's just like the other one, except it's a different method of calculating the resultant vector. Well, I hope you enjoyed this video, got something out of it. If you did, give me a like, a comment, subscribe to my channel, and thank you for watching.